Hi all. Today we are going to demo the workflow of the CentOS community container pipeline. To begin with, I need a project that has a Docker file in it and is ready to be containerized. As a developer, I do not want to worry about building, testing, and developing my application's container image every time I push an update to my application. That's where the CentOS community container pipeline comes handy. Today, I'll try to integrate the HTTPD project in my fork of upstream CentOS Docker files repository. All I need to do is put a file named ci.centos.org.yaml containing the metadata to be used to build the container image. Among other data, I have specified the name of the image to build and the version of the image to be built. Once the changes are done and I have committed my changes to my repository, I need to go to the CentOS container index repository, which is currently at github.com/rtmpro/centos-container-index. So I need to go to the project-index.yaml file, which is the index of all the projects integrated with the system, and edit it to include my project, which I name as CentOS, and I'll paste the link to my repository. Since the Docker file is not in the root directory of my repository, so I need to specify the path related path to it. So, which in this case happens to be httpd-centos7 and a commit message, and I'll create a new branch and submit a pull request. So I've submitted my pull request. Once this pull request gets reviewed and accepted, my project is all set to automatically build, test, and deliver container images without me needing to even lift a finger. Since I'm the owner of this repository, so I'll go ahead and merge the pull request myself. Merged. Yeah, so the project index now contains link to my project. Now let us have a look into how the CentOS community container pipeline actually works. I've got a Jenkins instance at web.pco.centos.org. It has a job named cccp-index, which is configured to pull the container index repository at regular intervals. On run, it creates or updates jobs for the projects listed in the container index. We see such jobs getting created over here. The jobs created for the individual projects in turn polls the remote project repositories and schedules container builds for them on our container build, test, and delivery pipeline, which is powered by OpenShift. Once this job runs, we see that a build is scheduled on the OpenShift server we're running. Now we'll take you through how we use OpenShift to empower our build, test, and delivery pipeline.
So from Jenkins it will trigger the build system of the OpenShift, which is consisting of mainly three phases: build, test, and delivery. Then it is one internal registry and one external registry is there. From Jenkins job, which is triggered by Git, that Jenkins job is triggering this build phase of this OpenShift build system, which is basically building the whole Docker file which is there in the source code. So it will go to the source code and clone that Docker source code repository, and it will build all the steps one by one. It is saying successfully built the image. Then it is pushing that image to the internal registry, which is OpenShift internal registry, keeping the tag as test so that the test phase can pull it. Now once this is pushed successfully, then it will untag and clean the local environment. So as it is pushed to the internal registry, it will trigger the next phase, which is test. So here if you see, the test phase has been triggered. Then it will run all the tests which are there in the /test. This location is variable, it can be anything. So it will run the test script, it will pull the image, it will run the test script. If the test is successful, then it will push that retag that image as release ready, and then it will push to the internal registry. So here for example, we have just pulled the image, retagged it to the release ready, then we are pushing it to internal registry. So once it is pushed to the internal registry, it will automatically trigger the build phase, delivery phase. So in this delivery phase, it will pull the image from the internal registry. Then it will run the delivery steps. Then it will push the final image to the external registry, which is outside available. So the whole process is, it is after the Jenkins is triggering this build, it will trigger the build step, which is building the image from the source code. Then that will be pushed to internal registry. Once it is over, then test is there for test. After the test, it will again push to the internal registry, and after that in the delivery page, it is pulling from the internal registry and pushing it to the external registry, which is publicly available. So from the Git source code, it is providing an image which is build and tests and has been tested. So according to the source code's test, build and test script. Verification, we are just pulling that build image which is pushed to external registry. So here we are checking there is no image except this CentOS 7 and latest. Now we'll be pulling that build image from the external registry. Here our dev 3243 is the external registry. So here we are pulling that image. Here it is saying that it has downloaded one new image from the registry which was pushed. So if we see now, it has got the image which was pushed from the OpenShift. This is the whole process. So anyone can anyone can raise a pull request in the Git repository, and he will get a built and tested image from the external registry.